So now how can you compare the salinity distributions in different estuaries? And here is a trick. What you do is, instead of using distance, you use normalized distance. What is normalized distance? It is distance divided by the total length of your estuary. And this is what's done here in this sketch for 4 different estuaries. Normalized distance starts at 0. And this is essentially where the salinity starts to increase from very low. Okay, so this is sort of the starting point of your estuary. Okay, this is the head of your estuary. And then on the other side, you have a 1. And 1 means you are in the ocean, the seawater environment. And if you do that, you can now plot salinity distributions for different type of estuaries. And we also normalize the salinity distribution. We use a salinity ratio. Okay, it's the ratio, it's the mean salinity, the vertical average salinity, divided by the ocean salinity. And again, you get a ratio, you get values between 0, which means freshwater, no salinity, and 1. 1 is seawater salinity. And you can see the different shapes. Okay, here you get different shapes, okay, for the Bay of Fundy. And this is what we call a vertically mixed estuary. Vertically mixed estuaries have a seawater over a long distance inside the estuary, and then you have a transition zone, okay, which is the vertically mixed. Have a look at the examples of estuary. This is a transition zone, and then you're in freshwater environment. On the other hand, you have, if you have strongly stratified estuaries, you have a low salinity along most of your estuary, and often the salt wedge is found in the adjacent ocean. Okay, here's one example for a stronger stratified estuaries, Connecticut River. You can see here. So now, so what's the next step? Okay. The next step, well, what you could do is, indeed, you could go to a positive estuary, measure the salinity at different locations, and plot your curve using the same diagram. And there you already get a good idea of what type of estuary you have. Okay, but we want to go one step further, because you can actually express these shapes here with an equation. Okay, and we talk about that on the next slide.